Okay, so today we're going to be talking about the area between two curves. So we could start it off with, let's just draw a little graph here. Oh God. We're going to have one graph, which is say, just go like that, sure. And another one, which just comes like that. Awesome lines. And we'll call this one g of x. This one, h of x. So, and then we're going to find an area between. So let's say between this point here and this part here. So all the area between that. And let's say this is A here, and this is B. So then now essentially we have a formula for this, and it is the integral between from A to B, and it is the integral from A to B of g of x dx minus the integral from A to B of h of x dx. And then we can use that to find the area between these two curves. And then essentially it is necessary to know which curve is the one that's on top and which is the one that's below, and that you'd have to use the one above minus the one below. So then the other kind is when we have two graphs that are intersecting each other, and I'll just show an example of that. So we could have another greatly drawn graph, and we could have this graph here, which just drops below, comes up, sure, and a graph that just goes straight. And then we have, if we say between B, which is, let's put it here, sure, and A, which we'll just say is at the y-axis here, and we'll put our B here. So essentially we got to find this area here, and then we'll have an intersection point, which we will call C, which is just right here. Oh, that great thing loves to flash. Then yeah, this little part here. So for that, we have another equation, and that would be the integral from this time A to C, because we're going from the part that's above the first graph. We need to find that area first. So then from A to C, g of x minus h of x, and I forgot to say which one is my g of x, which one is my h of x. So we will say that the top graph here is g of x, and this graph is h of x. And then we have to then, because this case, we have to add the part that is below. So then we will add from the integral from C to B now. And that would be of, in this case now, h of x minus g of x dx. This is because now this part is, now the h of x graph is above and the g of x is below. So we now have that equation, which can be used to find the area of graphs that have a point of intersection. Okay, so we have one other form also which is used, and that's the area in terms of y. So let's do another graph here. And then, so now we will have to be a little different. Say we have one going like this, and one going like that, sure. And we're trying to find the area, but instead it's going to be horizontally here. The area from this point to here. And we will make, again, A here, and we'll make B above. So we're trying to find all this area. Okay. And then, okay, yes, so we'll classify this one as our h of y now, realize instead of x, because it's in terms of y, and then we'll have this one as our g of y. And then now, the formula, it is the exact same. It is the integral from a to b of g of y minus h of y and just dy. And then in this case now, instead of being the top graph always minus the bottom graph, it is the rightmost graph minus the leftmost graph. So the most positive minus the most negative graph. And that is the equation that we use for it. Okay, so now we're going to try an example. This is one of the textbook. It is find the area of the region between y equals 3x squared plus 12 and y equals 4x plus 4 over the interval of -3 to 3. So we have this picture here, and that we can determine here that our f of x will be 3x squared plus 12, and our g of x is 4x plus 4. So we can use the equation from -3, the integral from -3 to 3 of f of x dx minus the integral from -3 to 3 of g of x dx. So then we could then plug in our functions, which will give us integral from -3 to 3 of 3x squared plus 12 dx minus the integral from -3 to 3 of 4x plus 4 dx. And then from that we could find the integrals, which would be x cubed plus 6x. That would be again from -3 to 3, and then that minus 2x squared plus 4x from -3 to 3. And then from there we can plug in our values of 3 and -3. So we're going to end up with 3 to the 3. Oh gosh, that's a little far away. Whoa. The 3 to the 3 plus 6 times by 3. All of that minus -3 to the 3 plus 6 to the -3, 6 times -3. And then this whole thing all together minus 2 times 3 squared, because this is now our second function of 2x squared plus 4x, and then that plus 4 times 3, all that, then minus 2 times -3 squared plus 4 times -3. lot of brackets going here, but it's all necessary. Then that will give us now this together will be 45 minus negative 45 minus 30 minus 6. And that will give us a result of 54. So that would be our area of the area between these two curves here.